Canary Islands and Mount Tide a potential solution to climate change? Mount Tide, located in the Canary Islands, is not only a majestic natural wonder, but also one of the world's largest active volcanoes. With its enormous size and incredible eruption potential, Tide can release tens of millions of cubic meters of lava each time it erupts. These lava flows are powerful enough to reshape landscapes, impact ecosystems, and even cause profound changes in the regional climate. However, rather than focusing solely on the potential threat of Tide's eruption, scientists are exploring another perspective, turning the volcano into a valuable resource for the global environment. Inside Mount Tide lies a large amount of basalt, a mineral-rich volcanic rock that can absorb cotwo from the atmosphere through the process of chemical weathering. Rock weathering is a natural phenomenon that has been going on for millions of years, in which minerals in rocks react with cotwo to form stable compounds such as carbonates, sequestering carbon for long periods of time. With its size and rich basalt reserves, Tide has the potential to be part of the solution to the current climate crisis. It is important that the approach is sustainable and does not damage this unique natural heritage. Scientists are developing less invasive mining methods, such as using advanced automation and analytical technology, to collect a small portion of Tide's resources without harming the ecosystem. This idea not only reduces greenhouse gases, but also lays the foundation for a more harmonious relationship between humans and nature. With its huge potential to absorb cotwo basalt from Mount Tide, could help slow down the pace of global climate change. This turns a volcano that was once seen as a symbol of destructive power into a new symbol of hope and renewal. Instead of being afraid of the enormity of nature, humans can learn to cooperate with it to protect the future of the planet. Rock weathering, an unsung hero of the Earth. Rock weathering, a natural process that occurs continuously on Earth, plays an important role in the carbon cycle and regulates the global climate. When rain falls, it dissolves small amounts of carbon dioxide cotwo from the atmosphere, forming carbonic acid, a weak acid. This acid has the ability to erode silicate minerals in rocks, leading to a chemical reaction that converts the dissolved cotwo into bicarbonate. This bicarbonate flows through rivers and lakes, eventually reaching the sea. In the oceans, bicarbonate becomes an important raw material for marine life, such as corals and shellfish. They use bicarbonate to build their calcium carbonate shells. When these creatures die, their shells sink to the bottom of the ocean, where the carbon is stored in a stable state for millennia. This not only helps balance atmospheric cotwo, but also contributes to the maintenance of marine ecosystems. However, a major challenge today is speed. Natural weathering is very slow, taking millions of years to produce a significant change in atmospheric cotwo levels. Meanwhile, climate change is progressing at a rapid pace, requiring more effective solutions to reduce greenhouse gas emissions in the short term. To overcome this, scientists are looking at ways to speed up the weathering process of rocks. One potential solution is to crush basalt into smaller particles to increase the surface area, thereby speeding up the chemical reaction. When crushed basalt is spread on land or in water bodies, it can absorb cotwo at a higher rate, contributing to reducing greenhouse gas emissions in the atmosphere. This intervention not only opens up the potential for practical applications of science, but also offers hope for responding to the global climate crisis. However, its deployment must be done carefully to avoid negative impacts on ecosystems and ensure long-term sustainability. Enhanced rock weathering, a promising solution. To speed up this process, climate experts have proposed a method called enhanced rock weathering. The core idea is to mine fast-weathering rocks, grind them into a fine powder, and spread them over large areas of land. This not only increases the surface area of rock exposed to water, but also speeds up the chemical reactions that sequester carbon faster. Volcanic rocks such as basalt are ideal candidates for this process. They contain silicate minerals that are easily weathered and are often found in large quantities in volcanic areas. Crushing and spreading these rocks over areas, such as farmland, not only sequesters carbon, but also improves soil fertility, providing a double benefit. Challenges of large-scale deployment. While the theory sounds simple, the implementation of enhanced rock weathering globally comes with a number of complex challenges. 1. Difficulty in measuring impacts. Rock weathering, whether natural or enhanced, is a process that depends on many variables such as rainfall, temperature, and geology. This makes it difficult to predict and measure the carbon sequestration effect. 2. Technical and ecological constraints. Mining, crushing, transporting, and spreading large amounts of basalt requires enormous amounts of energy and infrastructure. If the energy used in this process does not come from renewable sources, the project could cause carbon emissions that far outweigh the benefits. 3. Risk of side effects. Basalt may contain heavy metals or other hazardous chemical elements. Spreading this rock on agricultural land can lead to soil and water pollution, harming local ecosystems. Potential and future benefits of enhanced rock weathering. Despite these challenges, enhanced rock weathering is still a solution worth considering. Simulations show that spreading 10 tons of basalt dust per hectare of global agricultural land could sequester more than 200 gigatons of cotwo over 75 years. This is an impressive figure, especially when compared to the low cost and feasibility of this method. Implementing enhanced rock weathering does not require new technology, but takes advantage of existing mining and processing systems. At the same time, it opens up opportunities to integrate with sustainable agricultural strategies, helping to increase crop yields and protect the environment. Conclusion: you don't have to destroy a mountain to make a big change. Enhanced rock weathering represents an innovative approach to tackling climate change. Despite its challenges and risks, it shows that we don't have to destroy natural wonders like Mount Tide to achieve our emissions reduction goals. Instead, by harnessing a small fraction of the potential of volcanic rocks, we can make a big, lasting impact on the Earth's climate.